In this video, we're going to talk about colligative properties that depend on the number of solute particles, okay? But not exactly what the particles are, okay? So all particles are kind of treated equally. It doesn't matter if they're big or small or positive or negative. They all affect these properties in the same way. There's 4 different properties we're going to look at, okay? One of them is vapor pressure lowering. This is going to be the idea that the vapor pressure above a solution is always lower than the vapor pressure above the pure solvent. And this is going to lead to the idea of boiling point elevation. We're going to see that the boiling point of a solution is always higher than the boiling point of the pure solvent. And you can see this in action when, for instance, if you're making spaghetti, you might throw some salt in your water, and we'll talk about why that raises its boiling point and how that helps you cook your spaghetti faster. Also, freezing point depression, okay, dissolving a solid, causes the freezing point to go down. This is why we put salt on the roads in the wintertime, so that we have a lower freezing point, and so the ice won't freeze at a lower temperature. And also, we're going to look at osmotic pressure. I think you learned about osmosis when you took biology. So we'll talk a little bit about osmosis and what osmotic pressure is and how we can use it to purify water. We also need to talk about something called the vant Hoff factor. This is abbreviated with a little I. This is the number of particles a solute breaks into. So for instance, if you have a molecular compound, well, when you dissolve molecular compounds, they actually don't break into ions, right? So we say that I is 1. Okay, and this will be when they say you have a molecular compound, a covalent compound, something that's non-dissociating. So they'll give you sort of hints there. Now, ionic compounds are a little more complicated. If you have something like sodium chloride, hopefully you can see that that breaks into sodium ion and chloride ion. So every time we have 1 sodium chloride, we end up with a total of 2 ions. So I is 2. Okay. If I had calcium chloride, you can see that that breaks into calcium ion and 2 chlorides. So every time I have 1 calcium chloride, I have 3 ions. So I equals 3. Okay. If I have something a little more complicated, like say ammonium phosphate, okay, keep in mind your polyatomic ions. And this will make 3 ammonium and 1 phosphate. So I have a total of 4 ions, so I equals 4. Okay, and you're going to see that every time you have these I, it affects the colligative properties. And the larger I is, the more the colligative property is affected. So if you use calcium chloride versus sodium chloride, you can make your boiling point go higher or your freezing point go lower. Okay? And you're going to see that when we talk about each of these colligative properties, there will be an I in the formula. Okay? So the next set of videos is going to go through each of these colligative properties individually.